Welcome to the Virtually Speaking podcast. My name is Pete Flecha, and joining me as usual is my good friend, Mr. John Nicholson. John, how you doing, buddy?
Good. I'm feeling a bit old though. I'm listening to classic rock today, and just going through all the old hits and stuff, and I'm realizing, wait, classic rock is now from the year 2000. This is problematic. But it's also good to see some of these covers though, where they're taking "We Didn't Start the Fire" and redoing it. So it's good seeing kind of a new face on or.
No, yeah. When you say classic rock, I immediately thought of Aerosmith, Led Zeppelin. But yeah, I guess classic rock now is like I don't know what's in the 2000s. Three Doors Down. I don't even know.
Yeah, no, it's terrifying, Pete. But if you stay at something long enough, the time moves on, but things change. They're different and they're fun. So
well, yeah. I mean, heck, we definitely know things have been changing a lot. This past week we had a big launch. And for those of you that haven't seen, if you go to vspeaking.com or vspeakingpodcast.com or to our YouTube page, link below, you'll see plenty of videos that we did. We did an entire series on VCF, unpacking the various things, spoke to execs, spoke to product managers and stuff. But I knew that for the weeks following launch, I wanted to dive a little deeper with some of the experts in the various topics. And man, what a way to start with our good friend, Mr. Pete Koehler. Pete, welcome back to the podcast.
Yeah, thanks for having me, guys. I was trying to think when the last time that I was on this, and I don't know if it was that long ago or if my memory's getting worse as we go. So, or I'm just always confused over which release is what and when.
Yeah,
there have been so many releases of vSAN. It is hard to keep track of them all at this point.
Yeah, no, absolutely. I think the last time we talked to you was in I think it was one of the Explorers. It was either at Explorer or the last release. But yeah, we can always count on you for bringing not only good information for the presentations, and your sessions are great. Blogs are good. You've done some great blogs for VCF 9 that I'll be linking to in the show notes. But man, I don't know if people know this or not, but Pete is like the wizard of PowerPoints. He makes the greatest animations, and really anything that's, if you've ever seen a really detailed slide as it pertains to vSAN, I'm pretty sure Pete had his hands on it. So we're going to walk through some of those because I've been sneaking at this deck for at least a month, looking at all the various topics for vSAN as it pertains to VCF 9. And Pete, I know we only have you for like 30 minutes or so. I'm not going to rush you, but I would love to cover what you think some of the more, some of the more valuable points inside of this release of vSAN.
Sure. Yes, I think the latest release here of vSAN within VCF 9 is a great one. What we're seeing mostly, though, is maybe 4 general areas that many of our customers have been really asking about, and hence, they're actually being delivered here. One of them is global dedupe, which we're going to jump into a little bit further. The other is some nice improvements for vSAN storage clusters, which involves what we call network traffic separation. And then we have some really exciting news on the VM protection front, being able to perform vSAN-to-vSAN replication, which has always been a big ask for many of our customers. And then also, we can't forget some stretch cluster improvements that many of our European customers will always be excited about. So,
yeah. So, I mean, I'll let you drive, but I think there's a lot of good news around space efficiency. So maybe we can start there.
Yeah, you bet. So, when we think about deduplication, the real goal behind all of that is essentially to lower your costs. You can store more data in the same amount of physical space. And ever since the introduction of vSAN ESA, maybe the number one question that John and I have received is, oh, this looks amazing, but where is deduplication? Even before they knew anything about it, they would always ask about it. So we knew the pressure was on to make sure that we could get deduplication in vSAN ESA because it had been there within the original storage architecture. But we wanted to build it out the right way. And so with that, we've introduced a brand new global deduplication mechanism within vSAN ESA. And it really doesn't resemble much of what existed in the original storage architecture. First off is that it's a cluster-wide deduplication domain, meaning that we're going to look for opportunities to be able to deduplicate the data across the entire cluster. And that's very different than what we saw in the original storage architecture that looked at the disk group and things like that. The larger you increase that deduplication domain, the more likely it is that you're actually going to be able to reduce the effective capacity usage. The other part of it that we wanted to make sure is that we achieved was that we could achieve this improved space efficiency, but do so in a way that it wasn't going to harm the VMs in terms of their performance. So I think the magic behind of what we're doing here is that our deduplication mechanism within vSAN ESA is going to be a post-processing activity. So it's just going to run in the background. It's going to look at when we have available CPU cycles and perform that activity just on an as-needed basis. And because we have the full control of the stack itself, it's going to be able to really understand the difference between what's the data that has been most recently written versus what's the data that is the coldest. And we're going to go in reverse order. We're going to deduplicate the coldest data first because we know that that makes most sense. So these kinds of things will result in just much, much better effectiveness as far as deduplication, data reduction, as well as minimal interference with the guest VMs.
Well, and
Yeah.
that's really important, like the distinction there of what that dedupe domain is and all these improvements, because obviously with OSA, when it was per disk group, if you had 5 hosts with 3 disk groups each, you could have 15 different dedupe domains. And similar fragmentation dedupe domains has happened in storage platforms before. You'd have dedupe per disk pool or aggregate or LUN or per file, on a filer or things like that. But being able to crawl across all the blocks and all of the nodes globally across that entire cluster, that's a big deal in terms of pushing really high efficiency.
Yeah, it was one of those things we had to make a decision about, how effective could we make deduplication occur, but then what are those respective costs? I mean, you can have a precise, very precise deduplication mechanism, but if it comes at such a cost in terms of CPUs, then that maybe doesn't make as much sense. But then we also have to factor in saying, well, look, one of the ways that you make a deduplication much more effective is you look at the data in very small levels of granularity, just 4K blocks, which is what we're doing here. So that improves your odds of being able to deduplicate the data, as well as making a much larger deduplication domain. Now, the next question, obviously, that many of our customers have been asking us already is, well, how do we actually dedupe the data that has already been written without, amplifying a lot of this effort on the back end? And it's really quite innovative. Here is what we end up doing is that, this isn't within the data path at all. We just assume the data path remains exactly the same. The data is persisted on those storage devices. But we recognize, of course, when the scheduler is not as busy as it may be during daytime or business hours. And it's going to go through and read each 4K block. And it's going to create a strong hash using a SHA-256 hashing algorithm. And it's going to hold this in a brand new object that is just for the purpose of holding this information about, well, what sort of unique identifier is this 4K block? Well, it's going to run through that process. And then when it finds duplicates, it's going to then, once it identifies the duplicate, it's going to move that data into a special object. And that object will then serve one or more VMs for that very same block. And we do that so that we can make sure that there are not any hotspots inside of a VM that would otherwise occur if you were just referring to the same block within a given production VM. So this process just runs in the background. There's no need to tune it. It adjusts itself each and every second. So, and that's much faster than any administrator would be able to adjust it as well. And maybe what's most interesting too about this new capability is that as the customers end up adding additional hosts, we also scale in accordance with that. So it's not going to create a brand new deduplication domain. We are essentially going to be much more efficient as the cluster grows in size. So just one really interesting aspect about it.
Yeah, that's definitely an interesting concept. As a matter of fact, it's a great segue, honestly, into some of the limitations of what I have seen in my past experiences with array-based deduplication. And so maybe we can talk a little bit about what some of the differences are between array-based deduplication compared to what this is.
Sure thing. Yeah. So oftentimes, what occurs with array-based deduplication is that the deduplication domain resides within the head unit of, or the controller of, the solution itself. So you're going to be looking at that head unit with the various shelves of storage devices that make up that storage array for that, and that will essentially define the boundary. But when customers scale or they grow their environment, oftentimes that's with another storage array. Well, when you approach storage in that manner, you're going to be splitting your deduplication domain in half, or thirds, or quarters, or however many storage arrays that you're going to be growing, and that there becomes a problem, because now it introduces the probabilities of, well, is my data over on the other storage array, could that be deduped on this array? But we will never know because they're fully split. With vSAN global deduplication, we are cluster wide, regardless of the size of the cluster. So it could be 4 hosts or 16 hosts. As you grow, it's simply going to expand that, almost in a similar way to when you grow a vSAN cluster by adding additional hosts. You have that single data store, and it just continues to be a single data store. That's sort of the value behind this approach.
Yeah, honestly, I would say that was probably one of the limitations. I know we're talking about array-based, but I think even for the original storage architecture, that was a limitation as well, right? Because I think wasn't it like on disk groups at that in the original version?
Yeah, indeed, and it was all by chance, really. I mean, if you had 4 disk groups, or 3 disk groups, or 5 disk groups, and whatever given placement of the VMs, and the likeness of the data, and how large the disk groups were, all of those contributed to its overall effectiveness. And we are really, and I know I'm really happy that the engineering team sat down in this very deliberate way and wanted to deliver space efficiency in the right way with vSAN ESA.
So Pete, I guess I had two final questions. One, how do I manage this? Is this just a global setting like it was with original storage architecture, or is there some more granular implementation of this? And also, what are the current caveats on deploying it today?
Yeah. So first off, we need to sort of clarify when it's going to be delivered. This is going to be shipping as patch 01 of vSAN for VCF 9.0. So it won't be at the initial GA release, but with patch 01. The next caveat that we need to be mindful of is that we're initially going to roll it out under sort of a qualification request, or what we call a technical qualification request, or TQR. This replaces the old RPQ process that maybe some may be familiar with VMware. And that's essentially asking for initial permission to use the feature. And then if so, then we'll give you the steps in order to activate it. And the reason why we're doing that is that we simply want to make sure that customers have their infrastructure built out in a proper way so that they can have an overall really good experience. Once that occurs, the deduplication will be activated via sort of a cluster level switch initially. but it's going to be controlled via storage policy, which is really exciting because it sort of drives back to that policy-based management for your infrastructure. So you can choose, some VMs to be fully deduplicated and other VMs not, and there may be some, security reasons behind the need for that. It really depends on the needs of the customer, but we give them that as the power of choice. We also do have a few limitations initially here on cluster sizes. We're going to be supporting anywhere from 3 to 16 hosts for eligibility here, and I would expect that, of course, to increase when it's fully released. But just on this initial part, that's what we're going to limit it at, and it will. Of course, because of some of those limitations, won't be available for things like 2-node clusters and stretch clusters as well.
Yeah, I would imagine, I could be wrong on this. Correct me, John, if I am. Probably 2-node in solutions are not probably the best, target for deduplication savings, right?
Generally, those are pretty small on capacity. That's generally not where the cost per gigabyte is. It's generally was the cost of like controllers or things, or or people are looking for physical space. I guess maybe might be the extreme there, but yeah, it's going to be these larger environments as we start scaling this up. That's going to be pretty crazy. And when you think about how much capacity you can put in those today, you have 16 terabyte drives on the HCL pretty commonly. And you put 16 to as many as 24 of those in one rack unit using the new ruler form factor drives. You're already at that 250 and up, 300 and something terabytes per host. And then, you start getting a multiplicative data reduction factor between compression and dedupe and other potential savings. Let's say you got a 4-to-1. At that point, you're already at, before your RAID overheads, almost a petabyte per host. I mean, the density here is getting incredible.
Yeah.
Yeah,
Absolutely.
and those are very real numbers too. We already have a lot of customers who are sizing their hosts for 300 terabytes or more per host. So you throw that deduplication on, and the density is going to be really phenomenal.
Nice.
Yeah, I mean, at that point, you put 30 hosts in a rack. I mean, we're north of 20 petabytes potentially usable in a rack. This is getting crazy. I mean, in terms of density. So.
Yeah, for sure. Well, a lot of VCF customers are going to be asking questions. I've already seen them myself in some of the enablement content we've been doing, talking to field, and certainly everyone wants to know how to get their existing vSAN environments into their new VCF environments. So maybe you can give us a little discussion around pathways to VCF 9.
Yeah, that seems to be the number one asked question for those who have really bought in to the idea of, I want to go full stack VCF in my environment. How do I do it? Well, our answer up until VCF 9 wasn't maybe as good as we wanted it to be, but we've made some nice improvements here really through the ability to import existing vSAN instances or clusters into a brand new VCF instance. And so what this is going to allow customers to do is really to have that path that they say, here's my existing infrastructure with my, I'm happy with my my given vSAN clusters. But I want to build out a new instance. So they can take their first vSAN cluster, for example, and they will convert that into a cluster that will be a part of the management domain. And then from that point on forward, then they can import using the VCF import tool additional vSAN clusters, whether they're storage clusters or aggregated vSAN HCI clusters, into their workload domain. So this is going to provide that nice path in order to sort of move their infrastructure forward.
And so just getting my verbs straight here, convert is where I take an existing cluster to build a management workload domain, build that first VCF instance, get that off the ground, bootstrap that in. Import is where I already have a management instance and I'm going to go, like the Borg, just go assimilate some other clusters into this environment that weren't necessarily greenfield brought up within VCF, right?
Yep, you said it better than I did, John. That's really that's really what it comes down to is that just one of two options. The second option, that VCF import, that's going to be the one that is probably going to be performed the most there, because you may have several clusters. You just want to bring them in to this ever increasing VCF instance, and your workload domains may have dozens or hundreds of clusters, and so that process is going to be likely the more frequently used one than the other.
I remember a previous podcast we did with Glenn Sizemore when this was being launched back around the 5.2.1 era. And it was there still were a lot of limitations. This was like separate tooling. It's like some of it was like, okay, here's some scripts, go have fun. But it looks like this is kind of growing up and becoming a lot more mainstream in capability here.
Yeah, indeed.
Yeah, well, Pete, dealer's choice here. I know I think we did a pretty good job on space savings. Deduplication has been something that folks have been looking forward to for a long time. What's next on your list of tricks?
Well, I think given the number of questions we get about and the amount of interest that we get around vSAN storage clusters, previously known as vSAN Max for any sort of old episodes that anybody wants to listen to and watch, I think it's worth sharing about one really important improvement that we've made around vSAN storage clusters, and that's the introduction of network traffic separation.
Oh, yeah. Okay.
And what this allows customers to do is that they can build out a vSAN storage cluster, which is just as the name implies, it's going to be serving out storage for their various vSphere clusters. And what this will allow them to do is they'll be able to assign a VM kernel port or tag that VM kernel port, one for backend vSAN traffic that makes sure all the data is replicated and rebalances the data and repairs the data and so forth. But they'll be able to tag a second VM kernel port, preferably on another NIC port that they have. And that will serve all of the needs of the vSphere hosts that are mounting the data store for that vSAN cluster. So what this does is, in a way, it allows you to use multiple VM kernel ports for this responsibility of serving up storage. And it's really impressive because it helps solve several problems. One is that you're using more hardware really effectively in so many ways. So we've seen a substantial performance improvement in some internal testing when we have run through the use of this specific feature. So vSAN storage clusters essentially run at the same rate as an aggregated vSAN HCI cluster using this mechanism. The next part is it really helps you design an environment that is much more effective as far as your networking topology. So imagine a vSAN storage cluster that sits in a rack, and you say, you know what, I want to keep all of that back end of vSAN storage traffic just within the top of rack switches. Or maybe you just bought a brand new, nice, fast pair of switches, and you don't want the network team to even know about it. You can have that pair of switches serve the backend vSAN storage traffic, but then the front end traffic that is going to the vSphere hosts, those can be connected to the top of rack switches that may only be 10 gig or whatever they are. And it's a really effective way to sort of isolate out some of this very resource intensive storage traffic.
And what's the difference, for those that may not understand, what is the difference between the front end and the back end traffic?
So they can think of front end traffic is when you are mounting a data store for these other from these other vSphere hosts, and the VM. The VM instance is running on a vSphere host, and it's sending IOs to the data store. That is considered kind of the front end traffic. The back end traffic is once it lands on the vSAN storage cluster. How does vSAN make sure that it's fully protected, fully replicated, balanced, all repaired, all of these other activities? That's really sort of the simplistic way of sort of understanding the difference between front end traffic and back end traffic. A storage array sort of does something similar, but you kind of don't see it as much. The front end traffic would be just the connectivity to and from the vSphere host, and then the back end traffic would be inside of an actual enclosure in the system bus and so forth.
So what was interesting is I was messing around in the lab and setting this up, and a couple observations on going through this. One, this is actually really easy. You just go through to create a VM kernel port. You've got your vSAN VM kernel port. You have vSAN witness kernel port for doing witness traffic separation, and then you have vSAN storage cluster client. And you would just need to set that up on all of the hosts in that storage cluster. By the way, we're up to 12 of these, Pete. And I think we actually just need a dedicated podcast to what the heck do these 12 different VM kernel ports do. If nothing else, a refresher for some of us, like it's like, what was NFC? I forget. But no, like, but going through, I did note when you set this up, you cannot tag multiple types of vSAN traffic to the same VM kernel port. So those are designed to be separate segmented VM kernel ports, and the UI enforces that. If you check one, and you try to check another, it just unchecks the other box.
Okay.
The other thing going through the setting up on this does prompt you when you create a storage cluster. So when you're going through the services, you're setting up encryption, you're setting up policy management. It says, do you want to use storage cluster client network? And it's just a checkbox. And you do have to set that up as you're setting up that vSAN storage cluster. So go create your VM kernel ports first.
Nice.
Yeah, this is one sort of thing to note is that this is for vSAN storage clusters only. So if you have an aggregated vSAN HCI cluster, you won't have this ability to sort of split traffic, which sort of makes sense because you're not splitting traffic out in the first place. The VM instances live on the same host where the actual storage resides. So there's not much of a need there in the first place anyway. But it is, just as John noted, just for a deployment of a proper vSAN storage cluster.
So Pete, with the last release, some of the newest improvements that people have been really excited about is the vSAN data protection. Building snapshots, being able to build, writable clones off of that, link clones, things like that. That said, we've historically always said a snapshot is not a backup. Part of that's you got a 3-2-1, you got to have a copy of that somewhere else. What is our progress on that?
Yeah, well, VCF 9 really helps solve that. I think most of the time, and certainly we saw it within VCF 5.2 or vSAN 8 Update 3 when we introduced vSAN data protection and the ability to sort of create these levels of protection for your VMs. We sort of had the resounding round of applause on going, this is great, but we need to protect it remotely as well. We need to protect it outside of the cluster. Oh, yeah. And that is exactly what we've done in vSAN for VCF 9. What we will do is we're essentially using the framework that was built with vSAN data protection to have that really nice and easy mechanism right within the UI. So you can set up your schedules for how often the VM is protected and your retention schedules and so forth. But we've extended this functionality so that you can set up a level of protection to where it is protected on a remote vSAN cluster. So it uses that same framework, but it is worth noting that this sort of remote protection functionality comes as a result of the VMware Live Recovery add-on. So that is just as the name implies, it's an add-on for VCF. That once you have that add-on, then that sort of unlocks the ability for you to protect VMs with a target location that is another vSAN cluster.
This is awesome. This is something people have been, asking for a long time. And as someone who's been a long time, storage person, I feel like you and I have always mused. It was kind of amusing that vSAN built $1 billion storage business, and the last features they put in were snapshots and replication, which I feel like generally it's the opposite. Mostly how people build their data services. But it is awesome seeing like the capabilities and how advanced and what they're able to build on top of this. Like the best did wait for last in some regards here.
Yeah, no, I think in so many ways we had these disparate mechanisms for that we could sort of achieve this functionality. You had things like vSphere replication that would help you move the data from point A to point B, but that had some shortcomings as well. You had limitations on number of snapshots that could occur within your RPOs with the older version of vSphere replication were 5 minutes. And now with this new functionality, VMware Live Recovery. Through VMware Live Recovery, we have RPOs that are down to 1 minute. What's really interesting, though, is that when we think about this approach where we're protecting the data remotely, most people are familiar with array-based solutions that will essentially snapshot the data and then replicate that data. Well, we do it a little bit differently, and there's a few reasons behind this. What we end up doing is we end up replicating the data first and then snapshotting it on the target. And what that allows us to do is really to create two autonomous or fully independent systems that really aren't fully dependent on each other. I mean, it really means that you have a lot of flexibility in the data manipulation. So in the example where you have something like VMware Live Recovery, which includes VMware Live Site Recovery, known as the old SRM, so to speak, that gives you the ability to say, okay, now I have this DR site that you have all of this flexibility that doesn't need to match up exactly with the source site. You know, a lot of times with array-based replication, you had to have almost the exact same model of storage array, and the firmware needed to be at the same levels and so forth. You could have a 16-host cluster at the source and a 6-node cluster at the target, and it's not a problem at all. You can also have retention of, let's say, 200 snapshots per VM at the source, as well as 200 snapshots per VM at the target as well. So a lot of
schedule
flexibility.
even, right?
Yeah, indeed.
So I could be going much shorter granularity of my snap recover points, but like shorter windows, but more of them more packed closely together on source, and then having a longer spacing, like a GFS type interval on my target, so that way I can have that go back farther if I'm trying to get around an invasive threat or find something older. Interesting.
Indeed, yeah. That's based off of really what our customers have been asking for, because that was their own requirement. Was they wanted to have these sort of highly frequent snapshots to address some cases, but then these other schedules and to meet the requirements of longer term retention and so forth. And so I think this offers the most amount of flexibility.
Another thing that you said that actually struck a chord with me, because I love reading like fire flood blood stories of things going wrong. And there was, I think it was the state of Virginia driver's license database. They had a system where they had two tightly replicating systems where they had corruption on one side and the snapshot metadata was tightly coupled. So it replicated that catalog and it just corrupted both sides. And they lost all the data and they had to go to tape. It was this like giant fiasco. The RCA was really, really entertaining read, since I'm, I guess was needing something to fall asleep to that night. But that like burned into my brain, and having these completely separate snapshot metadata catalogs, this provides a lot more durability against all kinds of weird failure modes and stuff out there that we might not think about on a day-to-day basis.
Yeah, and I think that was the entire goal of this. We knew that since we own the data path, we could have done this in several different ways, but this was a very deliberate approach to how we wanted to achieve this, to provide really maximum levels of flexibility for our customers. And when we think about historically, vSphere replication was a mechanism that was used by a large a percentage of our customers to achieve this result, but it had some limitations, and it had some quirks, and you had to be very aware of that. Well, we really remove all of that from essentially being the inhibitors to using this within our production. And maybe best of all is that it's just all built in to the UI and fully available via APIs as well, which was something that we didn't really have with vSphere replication either.
Yeah, and for those that are only listening to this, I would recommend watching the YouTube video as well, because we're definitely walking through some of Pete Koehler's awesome slides. And on this one slide, I can see the legacy vSphere replication, back in the day, 5 minutes, up to 24 continuous snapshots, now 200. And I know everyone pushed the 24. I wonder who's going to push the 200, and then what happens?
Yeah, and I can share with you that the 200 is a limit that was, they wanted to introduce some sort of limit that they could have within a test bed, so that they, it didn't have to stretch out. But conceivably, we know that it can go much higher if needed. So if we have customer requirements that come back saying, "Hey, this is great, let's do more, let's make it bigger," I don't think that that's unreasonable.
And one of the things we've talked about this is unifying the front end control, the APIs, the UI, all within vCenter database, things like that. Um, let's talk about the back end, because I remember, I had SRM, I had an appliance for that. I'd have an SRA I'd have to deploy, VR appliances. I know the vCenter data protection is its own appliance today. How many, am I just gonna have appliances everywhere? Am I collecting them like Pokemon cards here, or what are we doing in terms of making the infrastructure admin not have to go insane with managing all these things?
Yeah, no, indeed. I think that may bring back a few bad memories for some administrators that had to manage all of these, individual virtual appliances. As a concept, that always sounded like a great idea until they started adding up, and then it was like subscriptions. You never knew what you were paying for, managing, or doing anything. When it comes to the appliance for VMware Live Recovery, we've essentially consolidated this all into a single appliance. So you're going to have the vSAN data protection snapshot manager, so to speak. That is going to be built in to this one appliance that is also going to serve the needs of vSphere replication, which is also going to serve the needs of VMware Live Site Recovery. So we've combined these three independent appliances into a single virtual appliance. Now, if you were to have a very simple topology where you have a source site and you have a destination site, each site in that particular case would have a one of these appliances, as well as a vCenter server. Because again, we want to create an arrangement where you can have one of those sites no longer be available ever and still be able to recover. So that's really the need for that sort of approach.
I love simplification, although collapsing all of this into vCenter, it sounds like a great idea, but I feel like we're already kind of a clown car of services over there. So having just one appliance instead of 3 or 4 sounds like a great model.
Yeah, the good news is that there was I think they've been able to modernize those appliances in many different ways. They have several containers that run inside that virtual appliance that are lightweight and can sort of
Oh, so there's still
reinstantiate
some
themselves.
segmentation. Yeah,
Yeah,
that's nice.
yeah.
All right, so we deduped the appliances, Pete. So Pete, what's new with stretch clusters?
All right, so we have basically 3 new things that we want to introduce here in vSAN for VCF 9. One is the full support of stretch clusters when using a vSAN storage cluster. In the past, this was possible to stretch the storage cluster, but remember, vSphere alone has no understanding of the concept of fault domains or sites. And so we needed to build that in with vSphere so that it could understand that concept. And the result is that you can now create a fully disaggregated, almost like metro storage cluster that you would do with storage arrays without the complexity. So it's just much easier. We have so many customers running stretch clusters for aggregated vSAN HCI arrangements. Now they can do the very same thing with a vSAN storage cluster where they have half of the cluster in one site and the other half in the other site, as well as their vSphere hosts for those respective clusters. So they have this fully site resilient arrangement. And then the next improvement that we made that certainly we get a lot of requests for is the ability to enter a full site into maintenance mode. This is that notion of you being able to say, okay, I understand the concept about entering a host into maintenance mode, but I have this stretched cluster and we need to do some work over on one of these sites themselves. Well, you had to step through a lot of steps on that, and it was manual. And when we know it's manual, there were all kinds of issues that can come up. You accidentally skip a step, and then you don't know why things sort of failed on you.
Yeah,
we've introduced this mechanism that's just going to be built right into the UI. It's easy and really effective, and it takes a lot of the the complexity out of it. And not only that, just entering a site into maintenance mode, it will also help you exit that site out of maintenance mode once that occurs. Now, the third one is sort of tied into what I just mentioned here about sort of a site maintenance arrangement. We've had some requests from some customers in the past where they have a site that is being maintained. But what happens if you have a catastrophic failure of the other two sites? Can I get the one site that was under maintenance back up and running? And the answer in the past had been yes, but you needed to engage with our global support team. And it was sort of a manual effort. They needed to step through the process and kind of build things back up. Well, we wanted to introduce a way to make this easier for our customers. So we have what we refer to as a manual site takeover mechanism that will allow customers, if they run into this circumstance, they can go to that one site that was under maintenance and get it out of maintenance, but then make all of the objects available so that they can power up those VMs and they can have site availability again. Really nice feature for ensuring the durability of the data.
You guys, John, is this one of the areas that you're doing demos of? I'd love to see this in action.
I do not have a demo of this yet, right?
My goodness, man. You're the demo guy, man. You're supposed to have demos of this.
So the next one's fun because I feel like a lot of customers with 9, just because of the importance that VCF operations has in your environment. It's also, your license manager now, so everyone's going to be deploying it. Some people may not have spent enough time there, so they're starting to poke around in there. What's new for storage operations within Operations Manager?
Yeah, well, I think we're finally hitting the point where we can, make sure that there's proper visibility for storage-related activities within VCF operations. So we've introduced 3 brand new dashboards within VCF operations that are focused primarily on vSAN, although they can be sort of used for other scenarios. But they're going to sort of tackle some of the key areas that, as a storage ops person, you want to be able to know more about. The first part is this sort of overall storage operations dashboard. This is sort of this view that you would want, this overarching view of what's the health and well-being of my entire environment. vCenter Server has always done that really well, but only at the cluster level. But we know in VCF instances, you could have hundreds of clusters within several workload domains, and you don't have time to just kind of click through all of these different things. So that storage operations dashboard is really going to be hitting that. The next part is vSAN performance monitoring and just sort of getting a good overview there. We've historically had just amazing visibility into storage performance for vSAN. But once again, that was kind of a per cluster thing. And it was, if you had several clusters, you had to do a lot of clicking in order to understand that. This is going to consolidate that ability for you to quickly scan through the dozens of vSAN clusters that you have, so that you can understand if there's any anomalies from a performance perspective with many of your other vSAN clusters. And then finally, we have the ability to help do a sanity check, so to speak, on your new vSAN clusters that you're introducing into an environment, or even the existing clusters that are in place, and you just want to see if they're sort of operating in the best way possible. And this borrows some technologies and some ideas from an older mechanism that we had within vSAN, but now gets extended into VCF operations so that you can sort of do this quick test and verification easily across several vSAN clusters.
This is nice. This is like fleet management. It's something we talked to William about on our series, but just in general, having that fleet management of, like, instead, SPOG, single pane of glass of all these different areas. Mm-hmm. vSAN has always been known for having really granular, performance metrics. And it's so cool to think that you can actually now zoom out and see that, see all of your clusters together. That's pretty exciting.
I've had some some fun building actually a demo for this, which Pete will probably be playing now for those of you watching the video. But what is nice is it really is just kind of it's one dashboard. You can see all your clusters. You can even see the compute clusters that are connected to your storage clusters. You can see what kind they are. You can see where your health scores. This is that vSAN health score where it's rolling up. On the right, you can see latency versus IOPS, so you can see how much load is on clusters versus if they're experiencing performance pushback. There's actually a button that will appear over there that says diagnostics. If you click that, now you can go in and do those performance diagnostics, which previously you had to do at a vCenter level. And previously it really was only designed to be used during benchmarking runs with HCI bench, and it required a cloud connection. Now you can offline run that using operations, and you can also run it on just production workloads, and it'll come back and say, your cluster looks lovely. There's no problems. Or, you probably have some networking issues that we need to go sort through. So being able to do this and not have to go hunt in 8 different dashboards or go build a custom dashboard, like this is out of the box, ready to be a multi-cluster storage admin. So that's my deal.
We wanted to make sure that nobody put on their resume that they were dashboard creators for VCF ops. There's really no need. Yeah, if you need to customize them, that's great, but that's not something that should be a core competency of your of your days. So making sure that these things are there for you is really important, and I think this has been a great release for that.
Very nice. Well, Pete, I know we only have you for a little bit of time. I appreciate you sharing all the details. And John, I appreciate the demos. But all of this information, links to all the demos, to all the blogs, to all of the information is going to be found on the show notes of this podcast or in the details of the YouTube video, whichever way you're consuming it. But Pete, man, as always, we love having you on, and we look forward to seeing you at VMware Explore.
No, indeed. And thanks to you guys for the continued work here on Virtually Speaking. It's always so important for all of the communication that we receive from our customers. It always comes up. So I know it's really well served. And so, yeah, likewise.